In this video, we are going to talk about the quadratic formula. So we've been talking about what happens when we want to factor an equation and we want to graph it and find the x-intercepts and the axis of symmetry and all that other good stuff. So here we've got an equation in standard form. Maybe we put our imaginary -1 out here, and we want to try and factorize this equation. So we've got 1 times -8, which is equal to -8. So what are the factors of -8 that add up to -3? Okay, so that's going to be -1 and 8, 1 and -8, -2 and 4, 2 and 4. None of these things are going to add up to -3. So we say that this thing is not factorable. It is not factorable. But that doesn't mean that it's not that you can't graph it. That doesn't mean that it can't be put on the XY axis. So how do we do that? There is a thing or an equation that is found uh, through a process called completing the square, and that is the quadratic formula. Now, there's two ways to write this. Most people are familiar with negative b, who have seen this before. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a when you have your equation written in standard form. Remember, this here is standard form. Standard form. So standard form is when it's written out like this with your x squared, your x, and your constant. Now, in this case, or in the case I'm about to show you, you've got three new letters, A, B, and C. And if you recall from the standard form, our standard form is y equals ax squared plus bx plus c. So this b, this a, this c all come from these same a, b's, and c's. So in this case, let's say we've got this 1. This would be similar to the a, so we would drop a 1 in there. In this case, we have b. We've got a couple b's, and that b is -3, and that b is over here in front of our x. And then finally, we have our c value. Our c is the same thing as our c. Oh, and I forgot an a down here. I forgot this a down there as well. So the first thing that you do when you're using the quadratic formula is first you know what the quadratic formula is. The second thing you're going to do is you're going to identify what a is, what b is, and what c is. So in our case, a is 1, b is -3, and c is -8. So then all I do is I just drop those very values into my quadratic formula. So x equals negative b. So b is already -3, so we say -3 because I want to make sure that I'm dropping these values in exactly as it's stated here. Plus or minus the square root b squared. So again, I'm going to keep my -3, but I've got to keep that in parentheses, and that's going to be squared minus 4 times a, which again is 1, and times c, which is -8. And so this thing is all under our square root, and all of that, oh my goodness, all of that is divided by 2 times a, which is a 1. So now all you do is you do a bunch of computations, and you're going to get essentially the x-axis, or the x-intercepts here. So and that's why we say x equals. So x equals a +3 plus or minus the square root. Let's see, -3 squared is 9 minus 4 times 1 times -8. So that's going to actually be a +32 divided by 2. So our x is equal to 3 plus or minus 9 plus 32, which is 41, all divided by 2. So if I were to drop these things into a calculator, let's take a look. So we're going to have uh, 3 plus, I have to do this in 2 steps, my square root of 41, and all of that divided by 2. And when I calculate this, I should get one of these values over here on the right. 4.701, and look at that, 4.702. So if we do a little bit of rounding here on our calculator, we can see that we've got this same value right here. And now if we do the same thing with the minus, so let's just go up here, we'll bring that down and just do a quick computation, delete, and we'll put a minus in there, and we should get negative 1.7015, which is essentially this. So these two things, 3 plus square root of 41 divided by 2 gives us this. 3 minus square root of 41 divided by 2 gives us this. Now, here's a way that I like to write the quadratic formula. So I'm gonna put this down here, and I'm gonna change it up just a little bit. And I'm not really change it up. I'm just gonna separate it out. I'm gonna say negative b over 2a plus or minus, and then I'm gonna just do the same exact thing. B squared minus 4ac all divided by 2a. Now, why do I separate these? Well, first, if I've got two fractions and I'm adding or subtracting them, I have to have the same common denominator to combine them into one fraction. So that's why I can separate this out. If these two things are separate, then I can combine them into one giant fraction here. This is what mathematicians do, is they want to have one nice big clean formula, but what it does for us is it kind of hides the fact that this piece right here, this is our axis of symmetry. So if we were to take this, negative b over 2a, so let's see, negative b, which was positive 3. So if we have 3 over 2, right, that's what we came up with here. Negative b is 3 over 2a, which is 2. So our x value, our axis of symmetry, check this out. Our axis of symmetry is going to be 1.5. So if I draw my line here, I can see that it's going through 1.5. And I can also see my vertex, which contains the axis of symmetry, the x value is 1.5. Now, if I wanted to find the vertex here, I just take that 1.5 and I drop it back into my equation, and I'll get my negative 10.25. But it's nice to see that this thing here is the axis of symmetry. So then what is this? Well, if I'm considering this part right here, this is the starting point. This is negative b over 2a, and then I need to add something to that. If I add, do the plus, all of this, that's going to get me to this x-intercept. And if I have negative b over 2a and then I subtract all of this, that's going to get me to this x-intercept. So when I combine all of this into one computation, I'm getting this value or this value. I'm getting either of the x-intercepts. But when I break it apart into this and I just do two slightly different, or two separate calculations, but I'm still going through this whole process, I'm just breaking it into two parts, I'm also pulling out the axis of symmetry. So if I need to use that, I can quickly find it right here. Now, the more you use this formula, maybe you just say, okay, I always recognize that negative b over 2a is this value, and then the b squared minus 4ac divided by 2a is this value, or this whole thing. You know, like as you get more comfortable with it, you'll see some of that coming through. But, you know, as we're beginning, it's nice to see that this 3 over 2 is indeed our axis of symmetry. So this is our x equals for our axis of symmetry right here. The equation for the axis of symmetry. X equals 3 over 2. So that is the quadratic formula. So again, what do you do? How do you use the quadratic formula? If you look at an equation and you recognize that this thing is not factorable, identify your A, your B, and your C, carry in the signs with it, your A, your B, or your C, and you drop it into either one of these two equations. Make sure you keep, this is always the opposite of B. So if B is negative 3, it's going to make it a positive. If B is a positive 3, it's going to make it a negative. But make sure you keep track of all of this do your computations, and there's your x-intercepts, and there is your axis of symmetry. So that is the quadratic formula.